Dear students, in this video we will solve question 3 from exercise 3.3. In my previous video of trigonometric functions, exercise 3.3 part first, I have solved question 1 and 2. Okay, let's see question 3. Prove the following. In this first problem is Sin inverse 1 by root 2 minus 3 times sin inverse root 3 by 2 is equal to minus 3 pi by 4. Now in the solution, you write down left hand side, that is equal to sin inverse 1 by root 2 minus 3 times sin inverse root 3 by 2. Now we know that value of sin pi by 4 is 1 by root 2. You take this sign to the right hand side. In the next step you will get sin inverse 1 by root 2 is equal to pi by 4. Means value of sin inverse 1 by root 2 is pi by 4. Now we have to check this pi by 4 belongs to the principal value branch or range of sin inverse function or not. And range for sin inverse function is minus pi by 2 to pi by 2, and obviously this pi by 4 belongs to this interval. Therefore value of sin inverse 1 by root 2 is pi by 4. Again we know that sin pi by 3 is root 3 by 2, and take this sign to the right hand side, we will get sin inverse root 3 by 2 is equal to pi by 3. Again you check this pi by 3 belongs to this interval minus pi by 2 to pi by 2 or not. Obviously this belongs to this interval, therefore value of sin inverse root 3 by 2 is pi by 3. Now we will keep these values in the equation. After keeping these values in equation, write down here, this is equal to pi by 4 minus 3 times pi by 3. Now simplify this. After simplification, this is pi by 4 minus pi, and simplify this, we will get this is equal to minus 3 pi by 4. And which is this? This is nothing but your right hand side. In this way, we have proved left hand side equal to right hand side. Therefore, sin inverse 1 by root 2 minus 3 times sin inverse root 3 by 2 is equal to minus 3 pi by 4. Let's see the next example. Sin inverse minus 1 by 2 plus cos inverse minus root 3 by 2 is equal to cos inverse minus 1 by 2. We know that from the properties of inverse trigonometric functions, sin inverse minus x is equal to minus sin inverse x, and cos inverse minus x is equal to pi minus cos inverse x. We will use these properties here. Write down first left hand side equal to sin inverse minus 1 by 2 plus cos inverse minus root 3 by 2. Now, using this property, sin inverse minus x is equal to minus sin inverse x, we will put value of sin inverse minus half, that is equal to minus sin inverse half. And for this, cos inverse minus root 3 by 2, we will keep value pi minus cos inverse root 3 by 2. Now, from the table, we know that sin pi by 6 is half, therefore sin inverse 1 by 2 is equal to pi by 6, and obviously this pi by 6 belongs to the range interval of sin inverse function. Again, cos pi by 6 is root 3 by 2, therefore cos inverse root 3 by 2 is equal to pi by 6, and this pi by 6 belongs to the range interval of cos inverse function. You keep in the next step value of sin inverse half and cos inverse root 3 by 2. Therefore, this minus sign as it is, value of sin inverse half pi by 6 plus pi as it is, and value of this minus sign also as it is, and value of cos inverse root 3 by 2 pi by 6. Now after simplification, this is 2 pi by 3, and treat this as equation 1. Then see the right hand side. Right hand side is cos inverse minus 1 by 2. Again use property cos inverse minus x is equal to pi minus cos inverse x. We will get pi minus cos inverse half. Then we know that value of cos pi by 3 is half, therefore cos inverse half will be pi by 3, and this pi by 3 belongs to range interval of cos inverse function. Therefore, in the next step, we will keep value of cos inverse half pi by 3. This pi and minus sign as it is. Simplify this. After simplification, this is 2 pi by 3. Now, from equation 1 and 2, left hand side and right hand side are equal. Therefore, write down sin inverse minus 1 by 2 plus cos inverse minus root 3 by 2 is equal to cos inverse minus half. In this way, if you know some properties of inverse trigonometric functions and you remember the table of 0 to 90 degree, then it is very simple to find the values of inverse trigonometric functions. You must remember also range of corresponding trigonometric functions. Okay, see the next example. Prove that sine inverse 3 by 5 plus cos inverse 12 upon 13 is equal to sine inverse 56 divided by 65. Now let sine inverse 3 by 5 is equal to theta and cos inverse 12 upon 13 is equal to phi. Let these two examples in the left hand side, take one as theta and next as phi. Therefore, we will get sine theta is equal to 3 by 5 and cos phi is equal to 12 upon 30. Now again by Pythagoras triplet, here sine theta is 3 by 5. Consider a right angle triangle. This as angle theta. Sine theta means opposite side divided by hypotenuse. This is 3, this is 5. Therefore, by Pythagoras triplets, this must be 4. And for this cos phi, take the next triangle. This is angle phi. Cos theta means adjacent side divided by hypotenuse. Adjacent side is 12, hypotenuse is 13. Means by Pythagoras triplet, remaining side must be 5. Now, in the first triangle, then what will be cos theta? Adjacent side divided by hypotenuse, that is 4 by 5. Here, cos phi is 12 upon 13. Therefore, what will be sine? That is opposite side divided by hypotenuse, that is 5 upon 13. Or here to find cos and sine, you can use the identity sine square theta plus cos square theta is equal to 1, and keeping value of sine theta in that, you will find cos theta, and here keeping value of cos phi, you can find out value of sine phi also. Okay. Now we will use the formula sine theta plus phi is equal to sine theta cos phi plus cos theta sine phi. Now in this equation, keep the value of sine theta cos phi and cos theta sine phi. Value of sine theta is 3 by 5. Keep that here. Cos phi is 12 upon 30. Then cos theta is 4 by 5 and sine phi is 5 upon 13. Now this is 5 into 13, 65. Here also 65. Denominator is same. Therefore write down LCM 65. Here 12 into 3, 36 plus 4 into 5, 20, and addition of these two will be 56. Therefore sine theta plus phi is equal to 56 divided by 65. In the next step, you take this sine to the right hand side, you will get theta plus phi is equal to sine inverse 56 divided by 65. And in the last step, you keep the value of theta, that is sine inverse 3 by 5, value of phi cos inverse 12 upon 30. Therefore, we will get sine inverse 3 by 5 plus cos inverse 12 upon 13 is equal to sine inverse 56 divided by 65. In this way, we have proved the given equation. See the next example. Prove that cos inverse 3 by 5 plus cos inverse 4 by 5 is equal to pi by 2. Let cos inverse 3 by 5 is equal to theta, cos inverse 4 by 5 is equal to phi. Take this cos to the right hand side, we will get cos theta is equal to 3 by 5, and here cos phi is equal to 4 by 5. Again, we will use Pythagoras triplet. Here cos theta is 3 by 5. See the first triangle. If this angle is theta, cos theta is 3 by 5 means adjacent side is 3, hypotenuse 5. And by the Pythagoras triplet, obviously this remaining side must be 4. Therefore, you write down sine theta is equal to 4 by 5. For this, you again take the right angle triangle. Here cos phi is 4 by 5 means adjacent side is 4 and hypotenuse is 5 if this angle is phi. And obviously this opposite side must be 3. Therefore write down sine phi is equal to 3 by 5. Then we will use the formula sine theta plus phi is equal to sine theta plus cos phi plus cos theta into sine phi. Now you keep the value of sine theta cos phi and cos theta sine phi in this equation. We will get this is equal to 4 by 5 into 4 by 5 plus 3 into 5 into 3 into 5. Value of cos sine theta 4 by 5, cos phi 4 by 5, cos theta 3 by 5, sine phi 3 by 5. Now we will simplify this. Here denominator is 25, therefore LCM is 25. This is 16 plus 9, 25. 25 divided by 25 is equal to 1. Now you take this sine to the right hand side. In the next step, we will get theta plus phi is equal to sin inverse 1. Now keep value of theta cos inverse 3 by 5 and value of phi cos inverse 4 by 5 in this equation, and we know that value of sin pi by 2 is 1. Therefore for this sin inverse 1 you keep value pi by 2. Okay, in this way it is very simple to prove the given equation. See the next example. Prove that tan inverse 1 by 2 plus tan inverse 1 by 3 is equal to pi by 4. Here we will use the property of inverse trigonometric functions. Tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. Take the left hand side. Tan inverse 1 by 2 plus tan inverse 1 by 3. Here x is 1 by 2 and y is 1 upon 3. Now keep this in equation or use this property. This is equal to tan inverse 1 by 2 plus 1 upon 3 divided by 1 minus 1 by 2 into 1 by 3. After simplification, this will be tan inverse 5 by 6 divided by 5 by 6. See here, LCM is 6, 3 plus 2, 5, that is 5 by 6. Here 6 minus 1, 5 divided by 6, that is 5 by 6. And this is nothing but equal to tan inverse 1. And we know that value of tan pi by 4 is 1. Therefore, tan inverse 1 must be equal to pi by 4. This is equal to right hand side. In this way, it is very simple to prove the given problem if you know the property of inverse trigonometric functions. Okay. Then see the next example. Prove that 2 tan inverse 1 upon 3 is equal to tan inverse 3 by 4. Again here we will use the property tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. Take the left hand side, that is equal to 2 tan inverse 1 upon 3. This is 2 times tan inverse 1 upon 3. You write down that separately. This is equal to tan inverse 1 upon 3 plus tan inverse 1 upon 3. And we will use this property. Therefore, this is equal to tan inverse 1 upon 3 plus 1 upon 3 divided by 1 minus 1 upon 3 into 1 upon 3. Now, after simplification, this will be tan inverse. This is 1 plus 1. Denominator is same, means LCM is 3. 1 plus 1, 2, that is 2 by 3. Here, 9 minus 1, that is 8 divided by 9. Therefore, write down this tan inverse 2 by 3 divided by 8 by 9. And after simplification, this is equal to tan inverse 3 by 4, which is your right hand side. Okay. In this way, if you use the property of inverse trigonometric function of for tan, then it is very simple to prove such type of problems. Then see the next example. Prove that tan inverse in the bracket cos theta plus sin theta divided by cos theta minus sin theta is equal to pi by 4 plus theta if theta belongs to the interval minus pi by 4 to pi by 4, which is open interval. Write down left hand side equal to tan inverse in the bracket cos theta plus sin theta divided by cos theta minus sin theta. Now divide numerator and denominator by cos theta in the bracket. Okay. After dividing numerator and denominator by cos theta in the bracket, we will get tan inverse 1 plus tan theta divided by 1 minus tan theta. Because here, if we divide numerator by cos theta will get cancelled. Here remains 1. And here plus sin theta divided by cos theta, that is tan theta. In the denominator, cos theta get cancelled. Here remains 1 minus sin theta divided by cos theta, tan theta. Okay. Then we know that value of tan pi by 4 is 1. Value of tan pi by 4 is 1. Therefore, in the next step, for this 1, we will keep tan pi by 4. And here, not for this 1, but you know that in the product of any number, there is 1. Therefore, you keep here tan pi by 4. Why we are putting here tan pi by 4? Because we know the formula for tan a plus b, that is tan a plus tan b divided by 1 minus tan a tan b. If here is tan a, then that comes in the product of tan b. Therefore, we are keeping here tan pi by 4 plus tan theta divided by 1 minus tan pi by 4 into tan theta. Not for this one, but here 1 is in the product of tan theta. Therefore, we are keeping here tan pi by 4 to use this formula in the next step. Okay. Then in the next step, we will use this formula. We know that tan a plus b means tan a plus tan b divided by 1 minus tan a tan b. See here, tan a plus tan b, 1 minus tan a tan b. Here a is pi by 4 and b is theta. Therefore, in the next step, you write down tan inverse in the bracket tan pi by 4 plus theta. And we know the property of inverse trigonometric functions. Tan inverse tan x is x. Therefore, tan inverse tan pi by 4 plus theta must be equal to pi by 4 plus theta, because here x is pi by 4 plus theta, and this is nothing but your right hand side. In this way, if you know some properties of trigonometric functions and some properties of inverse trigonometric functions, then it is very easy to solve such type of problems. Okay, and such type of problems will be asked in the exam for 3 marks. See the next example. Prove that tan inverse in the square root 1 minus cos theta divided by 1 plus cos theta is equal to theta by 2 if theta belongs to the interval minus pi to pi, which is open interval. Then again take the left hand side, that is equal to tan inverse in the under root 1 minus cos theta divided by 1 plus cos theta. Then we know the property from the trigonometry which we have learned in our 11th standard. 1 minus cos theta is equal to 2 sin square theta by 2 and 1 plus cos theta is equal to 2 cos square theta by 2. We will keep these values in this equation. Therefore, this is equal to tan inverse in the square root 2 sin square theta by 2 divided by 2 cos square theta by 2. This 2 will get cancelled, and in the next step this will be tan inverse in the square root tan square theta by 2. You take the square root in the next step, this will be tan inverse tan theta by 2. Again, you know the property of inverse trigonometric functions. Tan inverse tan x is equal to x. Therefore, this is theta by 2. Here x is theta by 2. Therefore, tan inverse tan theta by 2 will be theta by 2, and this is nothing but your right hand side. In this way, if you know some formulas of trigonometric function, then it is very simple to solve such type of problems. Okay, in this way we have completed exercise 3.3. See you in the next lecture. Till then, goodbye.